These are the video solutions to the metric to metric conversion practice worksheet in MTB 1370 in Chapter 4. Now, when we're converting from one metric unit to another metric unit, there are many different ways to convert. One is converting by multiplying by a unit fraction by a form of 1. For example, on the first problem, we have 2,200 milliliters. So we could begin by writing what is known, or what we are given, which is 2,200 milliliters. We can times that by a form of 1, a unit fraction, with milliliters, that unit in the denominator, and liters in the numerator, because if you look at our problem, our answer has to be in liters. And then we can say, well, what is equivalent? How many liters is equal to how many milliliters? Well, we know based on the prefixes, 1 liter is 1,000 milliliters. So when we multiply this, the unit of milliliters will divide out, and we're left with a certain number of liters. So on your calculator, if you took 2,200 and divided it by 1,000, you would end up with 2.2. So our answer is 2.2. And remember, in the metric system, we can use decimals. We want to use decimals instead of fractions. So the answer is 2.2 liters. 2.2. Now another way, maybe a shortcut way, you could say, to convert from milliliters to liters is to use the mnemonic, King Henry died by drinking chocolate milk. Now if you take the first letter of each one of those words, let's say that again, King Henry died by drinking chocolate milk. That will give you the first letter of the most commonly used prefixes in the metric system. Kilo, hecto, deca. B stands for the base unit, which is meter, liter, or gram. Let me write that above that. The B is meter, liter, or gram. Then D is deci, C is centi, M is milli. And then there are two prefixes that you are not responsible for. And then we have micro. MC is the proper abbreviation for micro. So in this problem, we began with 2,200 milliliters. Milliliters starts with M, so we're at the M over here right now. So 2,200. And one nice thing about the metric system, it's all based on powers of 10. So when we're converting from one unit to the next unit, we either multiply by 10 or divide by 10. So in this case, we're going from milliliters to liters, and liters is back here at the base unit. So a liter is larger, so since a liter is larger than 1 milliliter, we're going to need less liters. So when we go to the left, from milliliters to centiliters to deciliters back to liters, we have to divide by 10 in each position we move over. So we divide by 10 3 times there, and when you divide by 10 3 times, you're really dividing by 1,000 like we did in the previous method. So the decimal point, each time you divide by a 10, the decimal point moves one place to the left for each time. So since we're dividing by 10 3 times, the decimal point moves 3 places to the left in between the 2's. So we would get 2.2 as we did before. And like we said previously in the decimal chapter, we do not include the trailing zeros. So it's just 2 and 2/10 without the zeros after the second 2. So if you'd like to use the King Henry method, that helps you realize that you're either dividing by 10 one or more times, which will move the decimal point to the left, and if you're going to the right from a left prefix to a right prefix, you are multiplying by 10 for each position that you are converting to. So in the next problem, we have 7.32 kilograms. 7.32 kilograms. Let me erase this up here. So kilo, so that's over here, it's 7.32, and we want to convert to grams. Well, one thing you should know is that in each kilogram there are 1,000 grams. So if you have 7.32 kilograms, you're going to have more grams than just 7.32. So again, you're going to the right here, so we're going to convert one place, two places, three places, because grams is one of the base units. Meter, liters, and grams, depending on what you're measuring. So we're going to have to multiply by 10 once, twice, three times, and when each time you multiply by 10, the decimal point will move to the right one place. So in this case, the decimal point would move three places to the right. So 1, 2, 3, so we get 7,320 grams. You could also do it by the unit fraction method or the dimension analysis method by taking 7.32 kilograms, timesing that by a unit fraction with kilograms in the denominator because you want that to divide out, and grams in the numerator because you would like that to stay. And then say, well, which one's bigger, a gram or a kilogram? And a kilogram weighs more, it's bigger. So you say, well, one of those is how many grams? And it's 1,000 grams. So you have to know that equivalent in order to make this conversion. The kilograms would divide out. That's why we put it in the denominator over here. And then when you multiply 7.32 times 1,000 grams, you would get exactly what we have in the answer blank. Now in the next problem, we begin with 6,500 grams. So grams, that'd be a base unit. And we're converting to kilograms. So we're just doing the reverse of what we did. So since we're moving to a larger unit, we need less of them. So we divide by 10 for each position. So we're going to divide by 10 three times, which means we're dividing by 1,000. So 6,500 divided by 1,000 is 6.5 kilograms. So we just use the shortcut method there. In the next problem, we're given a certain number of meters. We have 4.02 meters, so that's 4 2/2 meters. So we'll put that, since it's a meter, that's a base unit. And we're converting to millimeters. So 1, 2, 3 factors of 10 that we have to multiply by. 10 times 10 times 10 is 1,000, so we multiply by 1,000, and we would have 4,020 millimeters. In the next problem, we begin with liters, which again is a base unit. So we have 2.87 liters. We want to convert to millimeters. So the decimal point will move over 1, 2, 3 places to the right because we're multiplying by 10 three times, which is 1,000. And if you multiply by 10 three times, you would get 2,870 milliliters. 2,870 milliliters. Converting grams to micrograms, pay special attention to this because some students struggle with the prefix micro because it's so small. So we begin with grams. We have 73 hundredths of a gram, which gram is a base unit. So we start with a B for base, which is meter, liter, or in this case gram, and we convert to microgram. Now when we convert to milligram, we would multiply by 1,000 because that's 10 times 10 times 10. But microgram is 3 prefixes away from milligram, so we'd actually have to multiply by another 1,000. So when we convert from the base unit of gram all the way to microgram, we're actually multiplying by 1,000,000, 1,000 times 1,000. So it's a 1 with 6 zeros that we're multiplying by, which means the decimal point will move 6 places to the right because we're multiplying by 1,000,000. So right now the decimal point is in between the 0 and 1, but we have to move it 6 places to the right. So that would be the 7,3, but then there'll be 4 zeros after that because we had to move the decimal point over 6 places. So that's 730,000 micrograms. So we moved the decimal point 6 places to the right because we multiplied by 1,000 once to get to milli, and then 1,000 between milli and micro. So 1,000 times 1,000. Now in the next problem, we start with centimeters. So we're measuring length. And we begin with centimeters. So centi is the prefix that starts with C. So we put 570 under the C because that's what we begin with. And we are going to decimeter. You notice that's not DAM. DAM would be over here with deca. But if it's just DM, that's decimeter, which is right next to it, which means we are either going to multiply by 10 or divide by 10, but since we're going to a larger prefix and we are going to the left, that's the way the decimal point is going to go, is to the left, because we're converting to the left. So right now the decimal point is after the 0. We're dividing by 10 once, which will move the decimal point 1 place to the left. So our answer would be 57. It would not be 57.0 because we do not include the trailing 0. So our answer is 57 decimeters. And you could do that the other way as well. I'll throw in another example showing you the dimension analysis way or the unit fraction method. You write down what you start with, which is 570 centimeters. And you times that by a unit fraction with centimeters in the denominator, that unit in the denominator, since you want it to divide out. And what you want to keep as a unit, put that in the numerator. And now in this problem, the larger unit of measurement there is the decimeter. So start with one of those and say, well, 1 decimeter is 10 centimeters. Because if you look up here, centimeters is just one prefix to the right, which means it's 10 times smaller. And then if you were to multiply that out, the centimeters would divide out, and 570 divided by 10 would indeed give you 57, and the units would be decimeters. So 2 methods to do the same problem. So let's write 1.8 under the base unit, because that's how many meters we start with in problem number 8. And we want to convert to centimeters. So centi starts with a C, so we're moving 1 place, 2 places to the right. So we're multiplying by 10 twice, which means we're multiplying by 100. And when we multiply by 100, the decimal point, it's currently here, will move 2 places to the right. So if you moved it 1 place to the right, it'd be 18 decimeters. But one other place to the right would be 180 centimeters. So that's 180 centimeters. And when you go to a smaller unit of measure, the quantity will increase because you need more of the smaller unit. On number 10, we begin with 23 milligrams. Milli is over here to the right. Let's write a 23 under that, 23 milligrams. And we want to convert back to grams. So 1, 2, 3 times we have to divide by 10. And when you divide by 10 3 times, you're dividing by 1,000. So the decimal point will go 3 places to the left. So we'll have 0.023. It is crucial that you put that leading 0 in front of that decimal point if your decimal's between 0 and 1. Otherwise, it will be marked wrong. So you need that leading 0 in front of the decimal point. And the last problem we have on this worksheet is a problem where you begin with 5/10 of a centimeter. So centimeter is over there, 0.5, 5/10 of a centimeter. And we are converting to the next prefix that's smaller than that, which is millimeter. So since it's adjacent to it, we just have to multiply by 10 once, which means the decimal point will go one place to the right, which will give us 5 millimeters. You could also do this problem similar to the other methods using dimension analysis or the unit fraction method. Start with 0.5 centimeters, times that by a unit fraction with centimeters in the denominator, the desired units in the numerator, and the larger unit there is centimeters. So if we have 1 centimeter, that's 10 millimeter because it's adjacent to it. When you multiply that through, this centimeter and that centimeter will divide out as a unit because one's in the numerator and one's in the denominator. And we have 0.5 times 10, which is 5, and the units would be millimeter. So again, this is the solution to the metric to metric conversion practice worksheet in Chapter 4 of MTB 1370.